Hello, everyone. I hope you can hear me. We'll get started in a moment. Okay, can you hear me? If anyone can confirm in the chat window, please. If you're able to hear me, okay. Let me quickly check through YouTube as well. Give me a moment. We will get started in few minutes. Okay. Okay, great. So I feel that we are live now. Okay, so we have Abhishek as well. So Abhishek, would you like to give some introduction to everyone, or we can get started with it? So you are live now, so I can unmute you and you can have a talk. Okay, I guess Abhishek, we are not able to hear you. Okay, all right. So let me get started with it. Maybe we will have Abhishek towards the end. But firstly, thank you so much for your time and joining in. Okay, so what I'm going to do is I'm going to share my screen. Okay, and I hope it is now visible. All right, so I'm just confirming that if you are able to see my screen or not. Is it visible to everyone? Okay, great. Thank you so much, Divya, Anishant. Okay, so now I'm going to put that slide in the presentation mode. So maybe once we come out of this presentation, then I will look into your questions. So once again, thank you so much for your time, and thank you so much for giving me this opportunity to talk to you. And before we get started, I want to give a brief about myself. So my name is Suman Devnath. I'm based out of Bangalore, and I work with the developer advocates team with AWS. And I'm with AWS for last 1 year or so. And prior to that, I used to work for various companies like IBM Labs, NetApp, EMC, and Broadcom. So my core expertise was mostly towards performance engineering and tool development in various semiconductor companies. So I mostly worked on network cards like fiber channel on fiber channel protocol and SCSI protocol and storage. I'm not very sure how many of you are aware of that, but basically I worked on the storage side before I joined AWS. And now at AWS, I'm mostly focusing on machine learning and deep learning. And I basically work with all the developers around this region. So I take care of India and Sri Lanka, Bangladesh. So basically within APAC, and I try to help and work with you all students as well as professionals to help them to get started with AWS from an engineering standpoint, and so that they can build things which they actually actually they want to, right? So apart from this, I'm also doing my master's from IIT Jodhpur in AI. So that is something that I try to study, but not able to manage enough time to have a balance with work and the study. So yeah, you guys know much better than me, what it takes to become a good student, right? So in today's talk, what we are going to talk about is how you can deploy a machine learning model on AWS. Now, there are a lot of things that this particular topic can cover, but what I'm going to focus on is how you can deploy. So we will not focus much on the machine learning side. If you're interested, we can always talk about that. Since I was told that most of you are from web development background, and most of you are working for the hackathon, which is around web, API, etc. So I just thought that there are a few services within AWS which you may like to explore, and I hope that a few of you might get some credits as well later point in time, and you can utilize that to build something whatever we learn today in next 30-40 minutes. Okay, and before we get started, I want to make sure that that you should feel confident to ask questions. Okay, you can ask any question that you want, nothing specific to the presentation that we are going to talk about, or the demo that we are going to see, but ask anything. Okay, so don't shy, and don't restrict yourself from asking any questions. Okay, we would love to have some discussion around that. And also, if today time doesn't permit, feel free to reach out to me over LinkedIn or Twitter, whatever you prefer, and I can help you out wherever I can, whenever you need during your journey to build something on AWS. Okay. So what we are going to do today, so we are going to train a machine learning model, a very tiny model, and we will talk about it, what that model is. And if you don't know what a model is, it's you can just forget about it. Okay, I will explain you that what a model is, and then we will see that how we can host that model on AWS. Okay, and we are going to use a service called AWS Elastic Beanstalk. So we have a lot of services via which you can create a web application, but we are going to just talk about one of those service, okay, on AWS that we have. And then what we are going to do is we are going to use Python. We are going to deploy a small app using Flask API, and we are going to use the same model which we will be training in part one of this session. Okay, so what we are going to see, after 30 minutes is we are going to have a web application like this. Okay, and this is basically driven by a machine learning model which we will be training first place. So this is a wine predictor, wine quality predictor. This is a very common data set which people use in machine learning. So what this data set is, basically, you will be given a lot of information, a lot of data points for different kinds of wine that we have. Okay, and it can be a red wine, yellow wine. It would have its acidity, fixed acidity, citric acid amount, pH value, etc. And what we have to do is we have to make a machine learning model which can predict the quality of that wine. Okay, so we will be having three different qualities: medium, high, and low. As you can see in the screenshot, it's medium, right? Forget about this, number which we see in the bracket as 6. We'll talk about it, what that means. But basically, the idea is we will be building a machine learning model which can predict the quality of the wine when you give all this information to this application. Okay, and based on that, this estimated quality score will differ from medium to high or low. Okay, so this is the application that we are going to deploy on AWS using Elastic Beanstalk. Okay, so now let's talk about the machine learning part of it, and then we will jump into how we can deploy that. So, in a nutshell, in machine learning, since you all are from college, most of you are from college, maybe. So, what the only difference between machine learning and the stereo code that we used to write in computer science is this. Okay, so let me use my pen here. Okay, so basically, if you look at any computer science problem that you deal with, right? What we have is we always get something X, and we try to write the code for some function fx, and it gives an output y. Okay, so let's take an example. So let's say you have given a problem that take a number from a user and tell us that the number is a prime or not prime. Okay, this is a typical example that we solve during our first semesters, right? Or even before that, during these days we learn this during school days. If you have computer science, right? So in this kind of problem, you already know fx because you already know how you can identify a number is a prime number or not a prime number. That means you already know the formula. All you have to do is you have to write few lines of code which will take this x value, whichever is the number that user gives. So let's say user gives the number 7, right? And then it will output as let's say yes, or maybe in numerics, maybe it will output as 1, which will say that okay, this number is prime. And let's say the user passed 8, then y would be 0. That means it is not a prime number, and it is a prime number, right? So this is how a regular computer science problem that we have been solving, where we were always given x, and we always know uh, this function fx, and we always know this input, right? Or what we don't know is this y part, right? This is how computer science problem we used to solve. Now let's look into how it works in machine learning, right? So in machine learning, what happens is you will be given lots of input data, right? So you will be given, let's say x1, you'll be given x2, you'll be given x3, okay? And you will be given its corresponding output, let's say y1 and y2 and y3, okay? But you will not be given any function. Like you cannot first place identify that what is the relationship between x1 and y1, what is the relationship between x2 and y2, and so on and so forth, right? All you have is this input data. So this whole thing is your input data, okay? Where this is the input data, and this is the class, right? Or the labels you can think of. Now you have to come up with a function fx, right? You have to come up with a function fx such a way that fits all these input points with its output points. Okay, so that means in machine learning, basically, you were given x and you were given this y or the class labels, but this part is not given. Okay, so imagine that if you take the same problem we solved. Let's imagine that if this problem we had to solve through machine learning, which ideally people will not solve, but let's assume that if we have to solve this, then the data point that we will be having would be like this. So let's say x1 is 7 and y1 would say it's a prime number. Then x2 is 8 and y2 would be let's say no, it's not a prime number. And then you have to read through all those input data and you have to come out with a function fx. Now there are different types of algorithms that can help us to build a model which we will be training with all these input data points. Okay, and later on, once the training is done, you will come up with the function fx, and then you can ask the user, okay, now you can give me some number, I will try to predict something. Okay, but I'm not very sure whether my fx is correct or accurate or not, because in this classical computer science problem, you always know that this your fx is completely correct, right? Because you have formulated it, you know the formula how to calculate a prime number, right? So that's that's the basic difference between machine learning and classical computer science program that we have. So if you now think about it, what we have done is, in machine learning, what we have just discussed is you will be given a bunch of input data, not just one data point, but bunch of input data point and its class labels, or y, right? And this is something we call as supervised learning. Why supervised? Because we are giving the input data point along with its class. Okay, this is its class that this point x belongs to. Now, if you look at this example, if we have to consider this as a machine learning problem, we can define that as these images are x and its class labels are y, right? So this is an image, and what this image contains, it contains baby, picture of babies, right? Similarly, this is an image which is x, and the y would be a Labrador or a dog, right? So this is how x and y are given to any machine learning engineer, and then the machine learning engineer need to come up with a function fx using some algorithm, and we will be using one of those algorithm today. And using some algorithm, they have to come up with this function fx such that later point in time, given an input image, let's say this particular image, it should predict that what this image contains, or what is the object that is there in this particular image, right? So this is, we call it as supervised machine learning. The reason is our input data point is given along with its class label. If this was not given, only x is given, then we call that as a unsupervised machine learning, because there is no one to supervise, right? You don't know, what these data points are. Okay, so now how this all things work. So this is how it works. We have just discussed this, but just to refresh what we have just discussed, if we will be given an input data point along with its class label, and we will be using some algorithm. There are different kinds of algorithm that we have, and then we will do the training. So once the training is done, so the meaning of training is basically the algorithm will go, will read through all the data points that you have. So in this example, we have just seen one particular image, but if you are building any image classification a model, then you will be having millions of images, right? Millions of different objects in the images. So training, while when we say training an algorithm, what we basically mean is the algorithm is now going over all these images and trying to figure out the best fx function, because it will not get to a very good accuracy first place, right? The more and more image that you give, the better prediction that particular model will give you. And then you will do the prediction. So that means your model is ready. Now you can put it in the production, and people can send some image, and you can identify what this image contains, right? So you might have seen in the internet a lot of computer vision problems where you see cameras, and it can detect automatically that a person is walking through the street, or a dog is crossing the street, or whatever, right? So this is how, that is actually what is happening is, at that time, it's actually the inference that is happening, because model development and training all were done, and then it was deployed on those cameras. And what that camera is doing is basically it is just reading the image and doing the doing the inference. And whatever we see in the monitor with a small bounding box around the face of a person is actually the prediction. Okay, and obviously the prediction may not be correct always, so we have to always adjust the model. So maybe there are a lot of different parameters that we can adjust the model. So we will tweak that, and so that we can see that, okay, if my accuracy increases, then it's better, and I will stick to that particular algorithm, right? So it's kind of a trial and error cycle. You keep on trying, and you will get the best model over the period of time. So there are many algorithms available in machine learning. And what we are going to use today is one of those algorithms called boosting, which comes under ensemble learning. So if you are into machine learning or interested to learn, this would be some of the topics which you will be learning within first a few weeks when you get started with machine learning. So let's talk about this particular algorithm very quickly, and then we will jump into our web application. Okay? So before talking to gradient boosting algorithm, we need to discuss a little bit about decision tree, because this is something that we are going to use in boosting algorithm, gradient boosting algorithm. So the decision tree, this may not be that unfamiliar with you, because this is there even in the data structure that we have in computer science in general. But in machine learning, the concept is exactly the same. Let's say you are given the input features like this. So this image is just given for for representation so that you can visualize, but the data set is given in a CSV format like this. Okay, just imagine that you have an Excel sheet like this, and there are lots of rows, and each row contains the name of the fruit. Okay, apple, lemon, or yeah, here we just have apple and lemon, right? And they are given with different size and colors. So now you have to build a machine learning model which can predict which fruit it is given only color and size. That's all. Okay. So if you use decision tree, you will come up with something like this. So here you have only two features, right? So you can think of this as F1, and you can think of this as F2. So just like any other decision tree, as the name suggests, we have to pick one of the feature, and let's say it is the color, right? So let's say this is F1. Okay. So now what we will do is we will ask that whether the color is red, green, or yellow. Because if it is red, then I can say that okay, it's confirmed that it is going to be apple, because we do not have a green or yellow apple, right? Similarly, if it is yellow, it would be a lemon. But if it is green, then there is a probability that it can be a lemon or apple. So in this case here, we will be using feature 2 to make that decision, right? So here we are checking the size of that fruit. Okay, then we will branch out again to apple and lemon. So basically this is just asking multiple questions to your input data set. So in this case, we just have two input data points, right? For each point, we just have two features. So in our tree, this is a decision tree. It can go till depth 2, right? This is first level and this is second level, and then you actually have the prediction, right? So prediction can happen at this level as well as in this level, right? So why we can go only till depth 2? Because we just have two features here. Now, this is a core concept of decision tree. And imagine now that you might have a data set which has hundreds of thousands of rows in the CSV file, or maybe if you are talking about JSON file, you can think of thousands of features that we have. So in that case, making a decision tree is very, very difficult, right? And also you have to then decide which should be your root node, right? So now here we have just picked the color of the fruit, but in real world, if you have thousands of features, you have to pick the right feature. So there is a technique which we use. We call it as entropy, cross entropy, through which not cross entropy, it's just entropy, through which we can understand which feature is the right feature to start a decision tree. Okay, so that you can divide the data in the much better way. But in our small example, but just by reading all these rows, we can figure it out which feature should be the root feature. Root node. Now, this is a problem with a very large data set. So here, ensemble methods or boosting algorithm or bragging algorithm comes into picture, where what we do is basically we make small decision trees, lots of small decision tree, not one decision tree, and every decision tree is a weak model. So that particular model may not be that good. Okay, if you just use one of those decision trees, so you can think of this as a one decision tree, and if you think of this decision tree is not that good. Okay, similarly, this decision tree is also not that good. But when you combine everyone, right, then we become then we get a very strong learner or a very good model. Right? This is the essence of ensemble based methods. Now, what is gradient boosting? So what gradient boosting says is basically we will start with a weak model. Okay, we will just take one decision tree, and it should be a very small decision tree of length. That means it's a very shallow decision tree. Like no matter how many features that you have, your decision tree should be of depth 2 or 3. Okay, yeah. So even if you have an Excel sheet, let's take an example with 100 rows, right? And if you keep going deep into the decision tree, you might get into 100 depth, right? But what gradient boosting says is basically make small decision tree with just 1 or 2 depth, right? That means what, out of those 100 features, right, you will just pick one of the feature, let's say feature number 1, and you will check and you will do some branching, yes no kind of thing, and then you will check another feature from that 100 features that you have, and then you just stop. You don't do anything. So similarly, you do other weak models as well. But when you do that, what happens is you misclassify lots of data points, right? Because obviously your model is not that strong. So if you look at this particular picture, you have triangles and squares, and this is the decision boundary that you see here, right? This is the decision boundary, or this is the boundary that the decision tree has made, that okay, if if it is less than this, then it is they should be all triangle, and if it is something greater than this point, then it is all red square. Now if you see in this particular output of this particular small model, so you can think of this as small m1 model. This is a weak model 1, and if you see that all these 3 points are misclassified. So what gradient boosting says, that next time when you do the training, you should give more importance to this misclassified points. And that's how the next decision tree makes an decision boundary here. So now if you see, these 3 got correctly classified, but this particular point got wrongly classified, right? And not only this, even these 2, but these 2 are correctly classified by this model, right? So we are concerned about now this point. Now in the next model, we give more importance to this. So now you see that this has classified all the points correctly. Now if you combine all of these 3, we get a very strong model, right, which we have just seen in the previous presentation. So now we get a very strong model. So every weak model like M1, M2, and M3, they all did their own job in a right way, but there are a lot of limitations in each of this model, right? Because the accuracy was not good. But when they combined together, we get a very strong learner. So this is how gradient boosting works, where you can define how many such decision trees that you can have. Like here you have 1, 2, and 3. So this is a hyperparameter which we call in machine learning. So you can define it as 3, 4, 5, or whatever. Right. So now let's stop this boring presentation, and let's see how it looks like in the code. Okay. All right. So okay, I will answer the questions that you all are asking. Okay, after this the presentation. Okay, I'm just reading through. Okay, so let's go to command line. And if you are new to Python, there is something called Jupyter Notebook. So what I did is basically I went to the folder where I have my code. Okay, so which is actually, let me increase the font. Okay, and there is a folder called, so here I have just run Jupyter Notebook. Okay, that's all. And once you run that, there is a browser opens up, and it shows all the folders that you have in that present working directory. So here we have a IPython notebook. So you can think of it as just like a command line interpreter, but over UI over the browser, which you can easily read through. So now let's go through this particular Jupyter notebook, which I have already opened. Let me go up. Okay, so if you're interested, you can take this notebook and you can play around. These are common data set that you will get it everywhere, and we picked this up from UCI Machine Learning Repository, which is one of the leading repository for machine learning engineers. If you work with machine learning, you will probably come to this particular place, and you will find lots of data set you can play around. Okay, so now what we are doing, we will just quickly go over this because this is not the concern of our topic, but a few of you might be interested. So I'll just quickly walk through. Okay, so these are all very famous modules. So these are kind of gods for us. Once we import, we can use them. Magically things will work, right? So we are just importing NumPy Panda. This is for data loading and some numeric operations, and we use Pickle. We will see what this particular module is, and then we use matplotlib, which is a module which we use for plotting graphs. And then we use scikit-learn. So this is the most important module which we are using, or rather package. This is used for machine learning, model algorithms, writing algorithms, using their pre-trained algorithms, splitting the data and all of that. So we will see what I mean by all of this. Okay, so first place what we are doing is we are downloading the data. And one weird thing about this data set is basically, although they have the wine data, but they have in different files. One file is for red wine, another file is for white wine. Okay, so we are just loading these two data sets into two different variables using Panda. Okay, so you can do something like panda.read.csv, and you can give the path of this file. Now, if you see, if you just visualize the first 5 lines, you can use head function. By default, it just prints out the first 5 lines. You can see this is the data set that we have. Okay, fixed acidity, all these features. So you can think of it this as all features. So now, when we talk about decision tree, now if you can recollect, all I want is you should connect the dots. So now if you have to make a decision tree for this, you have to pick one of these features. So maybe this or whatever, maybe pH value. So you have to first decide which is the root node, right? And then you can keep on going down, down, down. So here we have lots of features, right? So we will not, what gradient boosting algorithm says is you don't have to make a very deep decision tree. You can make a very small decision tree. Okay? Although it's there is no harm even if you make a very deep decision tree, but that's what it says. So now what we are going to do is we are going to add another column because we are ultimately going to merge these two data sets into one particular data set. So before doing that, we have to have another column, which would be something like color, so that we know that which point is coming from which data set, right? So we are defining this two columns, which actually which with a heading of color, and it would be 0 for white, and it would be 1 for red. Okay, so now we are just concatenating this. Okay, so we are just adding these two pandas data frame, and now we will be having a separate column called color. Okay, so now, before we get started, what we generally do in machine learning is we do some data exploratory analysis just to see, what the data is, how it looks like, what are the different data types, and all. So there are a lot of functions that you can call. One of them is describe, which will tell you mean, median, standard deviation, all of that. You can get a feel. So if you see the count is all same for all the features. That means there is no missing data. Right, so and that's why the null count for all these features is 0, right, or no null it says, right. So this is a good place to have that understanding about your data. Now, if you see the data set contains something called quality, which we have to predict. So let's go up to see that particular field. So there is a field called quality, and this is something which we have discussed, right? That input is X and output is Y. So you can think of all these fields are actually X, or maybe this is X1, and this particular is Y1. right? So this is the actual class label. And once your model is ready, user will give you all these data points, but it will not give you this last column value, the quality, which you have to predict. Okay, so now in the training data, the data set that you have, let's see how many data points we have with different qualities. So you will see that there is a quality 9, numbering is like this: 9, 3, 8. So now what these numbers mean, for this you have to go to that website from where you have downloaded this data set. It will clearly tell you that what these numbers belongs to. So I've gone through that. So what they say is all these numbers are defining the quality of your wine. So higher the number, better the quality is, and it scales from 0 to 9. But if you see, there is no quality for, there is no data point for quality number 1, 2. It starts from 3 only, right? That means the data set is having missing, there is no data point with quality type of 0 or 1, right? But if you see, the number is quite huge, right? It's not equally distributed. Now, if you do a training with this kind of data set, what would happen is mostly your prediction will skew within these 3 types, right? Because these types of wines are more in your data set. That means it will be, it's more likely that the model will look for these, right? These predictions in future point in time. You can, one analogy would be, let's say, before, any exam, what we do is, we don't go over everything. We just go over one part of the subject. I mean, at least I do, right? But what happens is that means during the exam, right, I will be just remembering those things, right? But I will be not able to answer any other things which comes up in the exam. And what I would do is, even if the question is from other side, I will try to write something rubbish based on what I have studied, right? So you can think of it like that. It's a very imbalanced data in technical terms. There's a very imbalanced data that we have. So to visualize this, we can use that matplotlib and just see a histogram that what type of different data types that we class that we have with the number of data points. Now this is not good. So what we are going to do is, I'll just scroll down because they are not very important. Is we are going to merge the type of the quality of data wine. So we will merge 3, 4, 5, and we will define a new quality as 3. That means what if a wine belongs to 3, 4, and 5, we will just consider that as a quality 3. Okay, and 6 we will keep it as 6, and then 7, 8, 9 will belong to 9. So you can think of it like it's just kind of a median that we have done, right? So we have clubbed together all these 3 different classes as one class, and all these classes in the right hand side as one different class, and 6 we will keep it as another medium class. So basically, what we are trying to do is this 3 belongs to lower quality of wine, 6 is medium, and 9 is high. Okay, so now we have to update that data set, because the data set is having 3, 4, 5, and we have to make sure that wherever it sees 3, 4, 5, it should be 3, right? So this is what we are doing. Wherever there is a 3, 4, and 5, we will just make that change. Okay, so this is what we are doing. So wherever it is finding 3, 4, 5, we are changing it to 3. Wherever it is finding 6, it should remain 6. Wherever it is finding 7, 8, 9, it should be 9, right? So that's how the distribution we are doing. So we are actually doing some modification in our data set. So now although this distribution is not that good, but it's okay. We can play around with this. So now the distribution looks like this, and now we are all set for our prediction, or training our model. So how we are training this model? We are going to use scikit-learn, and there is a first there is a we are going to split the data into training and testing, because we need to keep some data point which we can use for testing the model at later point in time, right? So this is how what we always do. So what we are going to use is, we are going to use scikit-learn's function method called train test split. What it basically do is, you can give the data set, okay, and you can give the class label, and you can say what percentage of your data you want to be isolated for testing. So here we have given 0.2. That means 20% of the data will be reserved for testing. So imagine that if you have a CSV with 100 lines of data points, and if you mention 0.2, then 80 80 data points would be for testing, training, and 20 data points will be kept aside for testing. And those are not sequential. So it is not like row number 1 to row number 80 would be for training. It will automatically do the randomness. So basically, it randomizes the data points. So what we are doing is basically we are saving the quality as in a separate variable, and we are keeping all the features in a separate variable. Now comes the training, because we have already split the data, and now the split data is saved in these variables. Xtrain is for training data point, and Xtest is actually the test data point. Ytrain is the class label for Xtrain, and Ytest is the class label for Xtest. Okay, so this is how these two are paired. Okay, for test and training, class label and input data. Now we are going to use gradient boosting algorithm, which is an ensemble based method, which we can always pick up from scikit-learn again. And this is just one single line which will do everything what we have learned in the theory. Okay, so what it is doing is we are giving a random seed of 10. That means so that every time we run this code, we should get a same results. So there is nothing fancy about this 10. You can put any number, and then there is something called learning rate. So we'll not get into details of this, what learning rate is, but you can think of this as what XGBoost will do is it will keep on trying, right? And every time it tries, it will try to see the error. And based on the error, it will change something, right? What it will change, it is, we don't care as of now, but it will change something. So now learning rate tells you that how much it should change. So higher the learning rate, then drastic change it will make, all right? So you can think of it like as a brake pad in your car. All right, if you give a soft brake, then the car will stop gradually. If you give a very hard brake, it will just stop very hard, right? So that's but brake is very important, right? You have to have a right control over the brake so that the car stops exactly at the point where you want to. Otherwise it might hit a tree or someone in on the road, right? Similarly, learning rate is also like this. So it says that how much fast I should make change on myself, and how much slow I should make change on myself. Okay, and this myself is nothing but that model. Okay, so you can think if you want to read about it, you can think read about gradient descent. This is the algorithm that it uses, and we can ping me. I can discuss in more details like what this learning rate is. And then we have max depth. So max depth is nothing but that decision tree that we have seen, because this is going to use a decision tree. It is going to create lots of decision tree, and we are saying that the decision tree should be of depth, maximum depth 10. Okay, and then there is just one single function that we called fit, and fit is the function when you start your training. Okay, so you are saying the X features and the class label, that is your X and your Y, and now you are training. So basically this line is actually making that function fx, which we have seen a couple of minutes back. And then once this is done, you can do the prediction. But since we are going to deploy this in a web application, we are saving it using pickle, and we are saving it in one particular location. Okay, this is the location we are saving it in a pickle file. Now let's, this line should come in the very bottom, because we have just built the model. We have not tested that model, but I just thought to put it here. Okay, but at this point, we can just stop the demo here, because we are not interested in prediction in this particular Jupyter notebook, but still we will just go through quickly. So now let's say you want to see how good your prediction is. You can just take one of the data point, right? And you can just do an inference, right? So how you can do that? So let's say we will come here. So yeah, so let's say you have a data point. Okay, X test is your data point, and you are doing calling a function called predict, right? Predict proba is a method that it has, and why it is proba, because it's a probability. So it gives you a probability distribution of all these three classes, because you have three classes, right? Three classes because there are three different types of wine quality that we have, and if you add each and every three elements of this of each array, it will be one, right? Because probability cannot be more than one, and you have to pick the maximum probability, and the index of that would be the class, right? So this if let's take an example. Let's pick the first prediction, and why there is lots of elements here, because my X test is actually the number of test points from the data set that we have, which we have kept apart using scikit-learn, and it has not one data point, it has 20% of the whole data point, right? So that's why we have all the prediction for all the data points, and we are just picking the first one. And if you see the first point, we see that the prediction came out like this, and it is very clear that the first value is the maximum, right? And the first value belongs to category 3. That means this particular data point okay, belongs to a low quality wine. Okay, it's as simple as that, right? So that's all about it, and you can also calculate the precision, and precision is kind of 74%. Not good, but it is like that. So the point I want you to remember now is we have saved our model in a file. Okay, this whole file we have saved. Okay, so now let's go back to our presentation, and I'll talk about how we can deploy this. So we have something called Elastic Beanstalk. So what this service is, when you talk about any cloud infrastructure, right, you have to uh, think about a lot of things, right? Like storage, compute, database, networking, management tasks, etc. So there are you can always do this all in bits and pieces separately, and you can do some scripting around it, or you can use a lot of automation tools that we have, like AWS, like CloudFormation, CDK, etc. But how you can do that, as a developer. So in AWS, the way that you can typically run a web application is you will first provision, where you will just provision how many virtual machines you want, how much RAM, how much CPU, and all of that. Then what are the dependencies, what are the libraries you want, and then you deploy your code. And once your model code is deployed, then you just monitor it, right? So, okay, how many requests is coming, whether I have to provision a new virtual machine to my infrastructure or not, and all of this. So there are a lot of things that you need to think about, and all these are different services, which I don't think you need to know at this point. But just for your information, for compute itself, we have lots of services. For storage, we have lots of services. You can just go mad with the services that we have. But now you as a developer, you just want to run your application, right? You don't care about all these services. How you can do that? And you can do that using Elastic Beanstalk, because that is completely automated, and you don't have to worry about what resource to allocate, and how to scale, and all of this. Everything is taken care by Elastic Beanstalk. So all you have to do is you have to write your code, and you have to tell Elastic Beanstalk what language or what platform your code is, right? So like Python, Node.js, Golang, PHP, whatever, right? And it can, in the back end, it will create a load balancer, it will pick up a virtual machine, it will install all your libraries, etc., etc., etc. So you don't have to worry about anything. So how difficult it is to do? It's just three simple commands. Okay, so since you all are developers, and I assume that you don't like a UI, so these are the three simple commands that you have. So first is EB initiate. That means you are going to create an application, and then you will do EB init, which will create an application, and then you will do EB create, which will create that environment. So that environment means it will create that EC2 machine or virtual machine for you. It will create a load balancer and all of that, right? So this is the point where it actually creates all the resources needed for your application. Okay, and then you simply deploy it. So now let's look into this in hands-on. Okay, so let me close this. and let's go to the command line. Okay, so I'm still in the same folder, and now let's first go to this particular folder. Okay, EB Flask. So I'm inside this particular folder. Okay, so now, the first thing that we need to do is you have to create a folder. So I have already created, so that's why I went inside that particular folder. So the next thing that you need to do is you have to create a virtual environment, which I've already created, and I'm already inside this virtual environment. But ideally, what you will be doing is you will create some virtual environment. So I'm using virtual env, but you can use pip or whatever it is, like pip virtual environment. Okay, so you can create this. Okay, and once this is done, I'm not running this because I've already into the same environment, and then you just have to uh, enable it, right, or source it, right? So once this is done, what you have to do is you have to write your code, your actual application. So let me do an LL, and we already have an application called application.py, and our model which we have created, right? If you remember, let's go back. The model is actually saved under pickle folder, right? So now if you go to this pickle, we have this folder. All right. Okay. So now let's look into this application, right? So let me show you this application. Sorry. Okay, it's just got open into another window. Just give me a moment. Okay, so let me just close this. Okay, so this is the application that we have, and it is a Flask application. So we are using Flask, and these are the few variables that we have declared. And if you notice, these are the variables which are nothing but those column names, right? And if you go down, you will see that there is just one function which is doing everything. Okay, so we are going to read all these input information from the user from the application. Okay, and we will load it into Python pandas data frame, which is another data structure that we have, and these are the variables that we will save on the user's input. Okay, so user will be giving us all this information through what is that, a sliding bar, and we will be saving it into this particular data frame. Okay, and then we have to just load that model which we have created, right? So this is a model, right? GBM model, and if you look at if you go up, we have already loaded that model using pickle load and this location of this model. That means my machine learning model has already been loaded into this application. All I have to do is now do the prediction. So just like we did the prediction in the Jupyter notebook, we are going to do the prediction here using a predict prompt, right? And we are going to give all the features that the user passes. Okay, and then we are going to, in the Jupyter notebook, we have seen that the quality it is showing us C369, all these numbers, but that may not make any sense. So we are going to create a small hash, and then we are going to return that in a JSON. So we are going to use JSONify. There is a method, and actually this is a module, and we can just say what is the predicted value. Okay, and we will just send this back to our web application. That's all. It's very, very simple, right? So now let's try to do this. Let's first, before, just like we do in the development environment, let's first try to run this on our local environment. That means on my laptop itself. So let's run it here. Okay, so it says that it is running on this URL. So let's go to 127.0.01. Okay, so now if you see, let me change this and see if we get the prediction. See, I've just changed this white to red, and now the prediction got changed. So now if I change it something else, see, now it is saying it's of high quality, right? So you can just you can play around, and every time I make a change here, a new data frame gets created, right? And that is doing a new inference to this model, right? So it is working fine. So let me go to the command line and let's close this, right? So we have closed this, and now we are going to uh, create that elastic beanstalk application, right, using this. So the first thing that, if you remember, that what we have to do, we have to do and EB init, right? So let me just copy this command so that we don't waste time. So we are doing a EB init -p Python 3.7, and we are giving some name of the application, and there's the region. So in AWS, all the resources are available in different regions, right? Because it's a worldwide based service. So we have some data centers, and maybe you can think of just a data center. We have few data centers in India. We have few data centers in US, then Singapore, and all of this. So this is one of the region, US East one, okay, which is not Virginia. But before I run this, I want to show you in the UI what. And if you go to Elastic Beanstalk, okay. So if you come here, you will not find anything because there is no application, nothing is running. So see this, there is a welcome window that we see, right? There is no application, there is no environment. So environment, you can think of the resources that the application uses to deploy the application, and application is just a placeholder for your application. Okay, so now let's go and run this. Okay, so it has created an application for, but it has not yet created the resources that you need. Okay, so how you can check that? Now, if I just refresh this page, and if you go to application, you will find that there is an application created, right? It's just now created 557. And but there is no environment. That means there is no resources available to this, right? So to give a resource to your application, what we have to do is you have to create an environment. So you can run this command. I'll just again copy paste. Okay, you can give any name. Okay, we are just giving this name, but you can give any name. But now what is happening at this point in time is it is going to go to AWS, and it is going to first, it will zip all the content in this present working directory. So now it is uploading. So it has already zipped all the content in this particular directory, okay, working directory. And then it is going to upload that into the cloud in an S3 bucket. So S3 is our object storage. And then what will happen is it will create an EC2 machine or a virtual machine, and it will create that load balancer and security group, all of that. So you don't have to care about all of this, right? So you can always change all of that with your command line argument. So because here we have just given few options, like this is the application that we are going to deploy is a Python application, and the region is US East 1. But there are lots of other options that you can give so that you can configure it in the way that you want. But generally, as a developer, you may not, you are good with your default configuration, right? So you just do the init and create that environment. And if you see here, it says that it created a security group, it created a load balancer, and all of this. Now it is creating an auto scaling group. Now, if you go to UI and do a refresh, you will find that there is an environment, so which we have just created, right? And it is still going on. It is still, it is saying that you will see that it is still in pending mode. So it is still in pending mode. Okay, so let's wait for a couple of minutes, just 1 minute, and then we will be good. Okay, so in the meantime, I will just read through a few of the questions. Okay, so okay, so one of the question is, okay, let's wait for this. Otherwise, it will break the momentum, right? And I myself will forget what I'm saying. Okay, so let's wait for 1 minute. I think it should be done in a moment. So see, a lot of things is happening in the back end, right? If you think about it, so you are not doing anything. What you have done is you have trained a model and you have created and Flask application. That's all you did, and everything is now taken care by Elastic Beanstalk, right? So let me see where we are now. Okay, so now it is creating a CloudWatch alarm. So CloudWatch is the service that we have for logging and monitoring. So you can always go to CloudWatch and see, what is happening with your Elastic Beanstalk environment. Okay, it's now got created, and let's see. I just hit refresh. I think it will take a couple of moments more. Okay, so now it's saying that health is okay. So in case it fails for some reason, you can come to clauses and you will be able to find out what's the reason. So now this command, it came out from that command prompt as well. And now what you have to do is you have to just run eb open. Okay, this is through command line. But if you go through UI, you will already find that endpoint, right? The URL. Right? So let's go to this point. eb open, and it should automatically open this link, right? And now you see the same model is, but it is not running in my laptop. So if I now give you this link in, let me share it with you. Okay, so I just sent you in the chat. I hope you are able to see in the chat. You can just open that and see that you are able to do the prediction or not. You can always play around. Okay, so this is how easy Elastic Beanstalk is to deploy your application. And if you now see what has happened in the backend, is it has created a virtual machine for you. So how what virtual machine that it has created, you can come to configuration and you would know that it has created um, a virtual machine. So let me do this, which is more useful. Let me go to EC2, which is our service for virtual instances or virtual machines, and we can see that there is one virtual machine running. Let's go there, and if you see, there is one virtual machine which is running, and its name is also with the same prefix that we have created the environment with, right? And if you see, it got created at 2nd September at 5:59. Okay, so that also proves that I'm not bluffing, right? So this is how simple it is to deploy your web application on AWS using Elastic Beanstalk. Okay, so you can play around. And one important thing to note is Elastic Beanstalk is a free service. Okay, so it doesn't cost you anything. But what charges is basically the resources that it creates in the backend, right? For all of that, you will be charged. But Elastic Beanstalk is free, for your usage. Now, how to terminate? Let's say you are done with your application and you want to terminate. How you can terminate? You can simply run eb terminate. Okay? From the same working directory, you can just run eb terminate. If you just just for confirmation, you can just type in the same name and it is getting terminated. Now, if you go to the this UI, and if you refresh, you will find that it is going to get terminated. So if you come here, see this, it is saying that it is terminating. Okay, and once that command gets over, your environment will be destroyed and you will not be charged for anything. So if you want to play around tonight or at later point in time during your hackathon, and if you want to use Elastic Beanstalk, make sure that after your training, deployment, or whatever, you just destroy the whole configuration. You can always add this code in your GitHub, and you can just make a pull request and create the environment again. Okay, so with that, I'm kind of end of what we have just discussed. This is exactly the same thing. I just kept some screenshot because at times, if the demo gods are not with me, the demo doesn't work. So that's why I just kept few screenshots. Okay, so to hide from some embarrassment. So thank you so much for your time. And this is my LinkedIn and Twitter handles. So if you want to connect with me, always reach out to me for anything. Right, I would be more than happy to help you. And now let me check few of the questions. Okay, so so the first question is. Which is better for machine learning for beginners, machine learning or deep learning, right? Okay, so it is like this. It's just like you can always start with deep learning. It's not like you cannot, but I would recommend that if you have time, you should start off with machine learning because there are a lot of basics concepts that we have which are general in for in machine learning, and deep learning is just a subset of machine learning, right? So basically, what if you are learning deep learning, it is actually you are learning machine learning as well, right? So I would recommend that you can start with basic linear algebra or probability statistics. Don't get into too much of detail because you will lose the interest. I'm very sure. I mean, if you are like me, but gradually you can always go back and go deep dive. But first place, do have the learning in a much breadth. Okay, so you can ask how to do it, but don't have to get into very detail. Okay, how this is actually working. Okay, you can always it's always okay to know. Okay, to do this, I have to do this. To get this, I have to do this. But why it is happening, you can ask that question. But that question should not demotivate you, right? So let's say someone is saying to know deep learning, you have to do calculus. You need to be very good at derivatives, differentiation, and all of this. And if you get into there, right, you will lose the interest to learn deep learning, right? So don't get into that negative mode. So initially it's good to have the curiosity, but try to implement, right? Try to write code and see how things are working, and at later point in time, gradually you will get that confidence, and then you can go deep and see, okay, I did this 2 months back. I did not know how that prediction came like this, so let me go back and check the function that it has used. And then if you try to learn that maths behind it, even if it is very involved, you will be interested to know because you already have that context, right? So deep learning and machine learning is evolving, and every day it is things are changing, but the basics are always same, right? So, if you pick up any machine learning book, the things that the professors teaches us, these are all are defined in late 80s, even early 1950s. The perceptron, which is the basic building block of artificial intelligence or deep learning, it was like discovered in way back in 1956, right? So take your time, but I would recommend to start off with machine learning basics, linear algebra, a little bit of probability, and then you can jump into deep learning, or you can do parallel. Okay, so that's. I hope that that answers your question. If not, you can always reach out to me. I can help you with the resource or whatever you want. Okay, so with the increase the number of learners, it will lead to overfit of the data, and how to prevent it. Okay, that's a very good question. So there are different techniques for overfit. So for the people who are new to machine learning, what is overfit? Overfit is actually uh, when you have a training data points, okay, and you try to make a model where your training error would be almost negligible. So your training error would be 0 or 0.1 or 0.01 or something like that. So that means your model has mugged up your data point. So you can think of this as a few students in our class, right? You will find that they are kind of in Hindi we call it as a muggu, right? So they just read everything by heart and they don't understand. So that is kind of a model which we call it as a overfit model. That means if something he has just memorized everything. Now if you ask anything from that particular subject, he may be able to answer that exactly. But if you ask something left right, then he may not be able to answer it, right? So because there is the learning was not generalized, right? So he has not learned that concept. Similarly, in machine learning or deep learning, where we say a model is overfitting, that means it is not able to generalize. So that function fx that it has come up with, it is not a generalized function. Okay, so it is a very stringent function which is based on your data set, input data set. And one typical example of this is a decision tree with maximum depth. So when you have a decision tree with maximum depth, then it will become a overfit model, because it will be like it will do exactly like the training data points that it has, right? So there are different techniques. So you can cut down the decision tree to a smaller depth, and that's what the idea is. And there are a lot of different hyperparameters that we use, like learning rate and all of this. So you can tweak about that, and you have to tweak a different hyperparameters based on different algorithms to get rid of overfitting. Now this is all in machine learning concepts. In respect, in deep learning there are different hyperparameters like dropout and then regularization, etc. Those are the few techniques through which you can get rid of overfit. Okay, but that's a very good question. All right, so yeah, I think that's about it. I don't see any other question. So thank you so much, Abhishek, and every one of you who have joined. I'm really privileged to talk to you. Connect me with over LinkedIn, and you can post messages, ask questions, and if you have something good to say, you can always show it in public. I'm kind of I love to take appreciation, but if you want to criticize on something, I would prefer that you send me a personal message. Okay, and I can give you one more reason to cheer about. Today is my birthday, so you can wish me, and for treat you can contact me separately. If you're in Bangalore, we will catch up. Okay, so thank you so much for your time. I know that last couple of minutes of what I've said is not that important and needed, but I just thought to talk to you because I really love talking to students and people like you, and I can talk for hours. Okay, so reach out to me if you need anything in future, and you have a great evening ahead. Okay, thank you so much.